About is, as the title indicates, an underground parking structure, and what we do. Let me outline what I'm going to talk about. First, I'm going to describe what the structure is and give you some specific backgrounds and what we're talking about. And afterwards, I'm going to separate into two main portions. One is the evaluation during condition appraisal before we actually recommend and do repair, and some of the structural analysis and the thinking behind it and what we did to evaluate and to come to the conclusion how we recommend to repair. And the other portion is during the repair, there are other issues that we have to resolve and what type of analysis that we have done and to resolve the issues during the repair portion. The garage I'm going to talk about is Grand Park South parking structures, which is located right in the downtown area of Chicago. And this is a map. And what you will see, if I can, this is an actual typical downtown area. And the parking structure we're talking about here is right over here. You can see all this green area is the park district. And this is underground so that you won't see it from the top. It's all underground portion. And these major parking structures serve a lot of the downtown commercial areas. So a fairly busy area for parking. And this is the overhead view. What we are talking about is this portion. As you can see, there's quite a bit of greenery. And Chicago, our mayor is a green mayor, so to speak, and they want to keep it fairly environmental friendly. This is another footprint goes around. What I'd like to point out is this footprint of the Grand Park South garage is over a major road, rural road, a thoroughfare, and there's another one over here, plus this is some art institutes around, and those green squares is what it indicates is the entrance point. We actually have to put in some elevators to facilitate and upgrade the garage. This is some of the basic background information about that structure. The gross area is over 537,000 square feet, and we can serve about 1,700 parking spaces. It consists of two support levels. As you can see from the aerial view, is the entrance is coming from the street level and then go into the first support level, second level support, and then there is an on-grade support. The total repair cost is about $30 million. Now, this was built way back then. We have dug into the archive to find out a lot of those basic actual construction documents to find out when they built it, because this is recessed, and this is very close to the lake, as you can remember from the previous slides. There was major concern about hydrostatic pressure pushing on this structure. So actually the floor slab on grade is resisting a uniform distributed hydrostatic load, and there's a very different design than what we normally would as a slab on grade system. Let's go into what we did during the evaluations, and as many people talk about, those processes are similar: initial investigations and then detailed ones. When you walk into this garage before it was repaired, something really catch your eyes is you can see areas around the column like this. The rebars are exposed. Actually, you can see that kind of hummed up because it was pushing out because of corrosions. And this is not an isolated area. You can look around the drive aisles, and some of the patches is already gone. You can actually see exposed bars. This is a reinforced concrete structure, not a PT. And also you can see some of the yellow lines. We sounded and find out where the delaminations are. We did fairly detailed mapping about what the situation is. And if you look at this one, as you can see, a lot of the spalling and the delaminations around the column heads. And again, similar pictures of that. What it looks like is fairly deteriorated. We also do material testing to find out the condition of level of chloride. This is inside. We found out that the chloride level is fairly high. Now, we also look at the underside of the slab, And particularly, if you can see two things from this slide, you can see water dripping down. You can see the wet spot on the lower level. When you look straight up, there's quite a bit of corrosions. Now, that will give you an indication that salt has been coming through that construction joint and then making the lower level of steel corroding. And this is a close-up. It's a fairly bad situation, and you can see the corrosions on the lower level clearly started and then spoiling the concrete. This is another look of the delaminated area, and I want to point out is what this picture indicates is there has been repair done on top of the slab. And this is a very classical called the halo effect, or the ring effect around the patch area. So after they patch it, you can see the yellow line represented delaminations. The deterioration extended beyond that. Some areas looks like fairly good patches, but in fact, the delamination is already there. So what we did is, in order to get an overall picture, is we overlaid what we found onto a schematic drawing like this. And what we found out is all the negative moment areas delaminated. That caused some concern. If this is a two-way slab frame, and with all the negative moment area delaminated, we're going to have a problem. But we didn't see any problem. So the thing is, we go back, take a look, what's happening. So all the common procedure, we go out, make an opening to find out what is in there. And then based on that, see if we can get a better idea. Are we facing a dangerous situation? Do we close the garage? Or it is okay? And this is the first things that we have to resolve in our minds. So we make some openings, and this is a close-up. When we open up, remove some of the loose, after we remove the loose concrete and so forth, you can see there's not much of steel left on the first layer. Now, if you count on those steel on the first layer to do the job for the negative moments, they are not doing it. So this is a concern, definitely. And we also look at other areas that may be typical. This is another one. There's only one bar left on the top layer. The other one, the lower level bars, immediate below, are fairly well bonded, also start corroding. So we measure the depth and document it as any of the conditions appraiser would do. And based on those calculations, we have to try to do an evaluation of what happened. This is another area on a good patch area. What we saw is what the previous people did, the patching. We didn't do the patching. The previous people, when they did the patching, they replaced some of the top rebars, but they never touched the lower level rebars. You can actually see the upper corner, corrosion start actually around that area. Then that's why the corrosions for the lower level rebar is worse than the one on the top, because this is the patch area. They didn't touch the lower level, but this is still on the top of the slab. Now, based on that, we also, when your negative moment area is in trouble, you want to make sure that positive moment area, what situation it is. This is what we did. We open up, we look at the positive moment area in the middle of the slab, and we'll see what it is. First thing we observed, we didn't see any major shifting or deflections. No. We also see the bars are in pretty good shape. No extensive deterioration other than the one that is on the joints. Based on those, we did some evaluations. This is a two-way slab system. In essence, 100% of the slab reinforcing bars are no longer effective. The negative moment bars are gone. We try many different combinations. No matter what we do, if we take out the negative moment capacity, the slab is not going to make it. Now, the reality is the slab is not experiencing any distress. The only reason we can give to is the other one-way direction is taking up the slack. They're doing all the work. So it becomes essentially a one-way slab system. And also point out the fact the previous guy must know what they're doing. because when they did the repair, they never touched the lower layer. They only replaced the top layer of the steel. Even though the lower layer is corroding, they have to leave it in place and then patch it and change the top steel to the ones and leave the lower level intact. In this way, they keep the one-way actions always working, functioning. Basing on this analysis, we're saying there's no safety issue concern at that time. The garage is working fine. There's no need to do any particular thing. However, if we want to repair the garage, then we have to find out, this is a situation what we're dealing with. If we want to repair all the negative moment area, the lower level bar to the other directions, they start corroding. It's going to incur major cost for shorings and that before you can touch it. Because if you take the other bars out, the garage is not going to stand up. So on top of it, there's a lot of chloride in the slab. What we recommend is we take the entire slab out and build it to have a brand new slab structure. So that goes to the final. Based on all those backgrounds and analysis, we recommend to the owner it will be cheaper for them to replace the entire slab instead of come back and patching. They are already beyond the point. It is no longer cost effective to do just patchwork. So we did those life cycle analysis for them. And in doing the repair, we also encountered several areas that we have to clearly look into it. First, I'll outline this as 4 points. Is when we do repair, they change the layout. And also, the first requirement they ask us to do is we want to maintain the garage to be open. What it means is you can only do a certain portion of the repair, completely replace the slab, and keep the garage operating on the other half. And what it means is you have to cut openings. So we have to be careful when we analyze it, where we should make the terminations and how does it affect the entire structural integrity of the slab. When we replace the slab, take out the entire level, the column all of a sudden becomes not one single level column. Then you become a long column. We also have to check for buckling. And this is an underground garage. When you take out the slab is the diaphragm holding the side retaining wall together. We have to go and check for the lateral buckling. So there are a lot of issues involved when we go into and take the slab out and put it back in. There are other issues also is the shrinkage, the shortening, time-dependent behavior. When you put a new slab in, you're going to shrink. The columns, all the spacings are in place. And how are we going to take care of it? Let me go into, this is the original layout. The paint area is where the rams start coming out and go into all those areas. This is the before the repair. What the new design they want the layout to be, a totally different entrance. They want to close this off. So and that's where the areas we have to look into. Now later on they changed their mind, is well, it's too complicated and then to go into phase to maintain the garage open. So we have to close down the entire garage, make life a lot easier. But prior to that we have to do all the facing diagrams and how far they can go and then how many parking space they will need. And this is a cross-section of the before and after existing and the proposed, in which is right now before and after. You can see we changed the roadway, and then this is the new ramp coming down, and we take out those existing slab and then put the new one in. I'll show you that in the coming slides. And seldom you see a slab completely removed, and this used to be a floor here, and now it's open up. That's why we have to check the buckling load, make sure those things are okay. It turns out to be fine. We don't need to have additional restraint. And you also notice that there's some capital here. Those are unreinforced capital. We have a contingency in case they cracked it, then we have to totally remove it and rebuild it again. And also the other thing I want to call your attention to is there are rebars sticking out from here. We tell them not to cut it because that's how the rebars from the column come in and hook into the slab. Now, since we are rebuilding the slab, we have to keep this in place to re-anchor. We connected these columns to the slabs. This is one of the another look about during the demolitions and clear out the concrete. We have to tell the contractor to keep big pains not to cut off those bars going through the columns. As I said before, in order to maintain the integrity and then anticipate the time-dependent behavior of the new slab, we put in quite a bit of steel to control the volume change. And as you can see, everything is already set. Concrete has to go through the volume change with time. So we put in quite a bit of reinforcement to calculate just to take that. Now, you notice we do not use green bars. We used a regular black bars, but we use a good cover, and we also used the corrosion inhibitor to counteract a couple of layers to fight corrosions. One of the areas we do not want to go to epoxy bars is the epoxy bar increase the development length. You can see the amount of steel we're putting in there. If you put in epoxy bars, the percentage of the amount of steel will increase, and so we'll make it more congested. I'll show you about what we did on the support. This is the diagonal struts going in. Because this is below ground, we have to have these struts to take out of that lateral load coming from the soil pressure. We are very concerned about that, and all the way around the entire perimeter, we have to put this in place before any of the slab can be removed. If you look at this particular one, there's something of interest. Is you look at this diagonal strut coming in, anchor at the top, but you see this is an air panel, or the coming through, because behind it is the plenum for the air circulations. So there's actually a gap behind the wall before you actually see the retaining wall. So that's why we have those particular anchors up on top, spread the load out, and then go through behind the plenum to go into the retaining wall. Finally, we did that, we complete, and this is the new garage as it is right now. It's totally complete. And as you can see, it looks totally different. And then those are the brand new slabs, existing columns. So let me close in a very simple fashion. It's mainly three things. Redundancy saves the days, and this is always the case with structural elements. And sometimes we thought that if we count on a certain way, the way we designed it, and fortunately, that the buildings never listen to how we want them to behave. They behave the way it is, and they want to. In fact, we should learn from them. And so the redundancy essentially keep the Grand Park Garage up and running for a long time. And the other thing is the structural evaluation before and during repair is very critical. If we find out exactly what is the situation behind it, that dictates about what type of repair we should give to the structure. That makes a big difference. If we do not know all the intricacy, the previous guys in patching it start digging in below and remove all the corroded rebars, they're going to see major structural distress. And the final is we have to be careful during the repair to address how we change the boundary conditions of the new elements and how we can address and then design for those. So that's the end of my presentation. Any questions?
Yeah, I have a question. I noticed that you placed those diagonal struts on the existing slab, and just wondering that the vertical component of the force of that strut now sits on the slab that you are aware has diminished capacity. Were you able to really quantify the lack of, or the existing strength of the system as it was behaving as a one-way slab to be able to place those loads on it without any concern?
We actually checked that. We used that capacity to take that. In fact, you see coming in at an angle, going down. That's why we have to take it all the way back to exercise the slab.
Did you do any work to the parquet roof slab? And my second question is, did you apply a membrane on the new slabs?
What's the first question again?
Did you do anything to the parquet roof slab? Top slab, the top slab.
Yeah, we take the slab out actually because they're part of the roadway. So we have to put it back, But then the design has to be according to a different design criteria because belongs to CDOT. The second question
was, did you place a membrane on the parquet slab?
Yes. There's a different membrane put in. The roadway coming down it was not concrete. We used the asphalt. So there was a membrane on top of the roadway. But then it's integrated with the roadway asphalt roadway.
And there was a membrane on the parquet slab as well?
Originally, the first supported level, is that what you're talking about?
Yeah.
We proposed to have a membrane. Because the budget cuts, they don't want the membrane to be put in. So as a compromise, put in the silane sealer. So we will keep an eye on it. If the things start, the chloride contents going up, we'll recommend a membrane. We still want them to put a membrane. It's just a budgetary problem. Okay.
Could you determine whether there was any calcium chloride in the original concrete mix?
We didn't go into whether as a calcium chloride. We know there's a high chloride content throughout the profile. Now, it could be from calcium chloride. It could be from with ages, the chloride infiltrated from the top. We did not differentiate between the two.
You couldn't check from the as-built records from the original building, the original floor?
We do not see the as-built building. It was way back then. Now, however, we knew the guy who designed the base slab. So I was able to get hold of that calculations, not the drawings.
How long had the spall repairs been before you did your analysis where you noticed that halo impact?
As far as I remember, there's a couple of people in Walker get involved in this project. And prior to we get involved, at least I know there's a number of firms working on it. Because before my previous life in Walker, I also worked on that project. So there's a number of engineering firms did that repair. I do not know whether that was the situation before. But the halo's effect is very clear.
Okay, thank you, Nam.
Thank you.